Okay students, in today's class we are going to see what ICs are. IC means integrated circuit. Actually it is the assembly of several electronic components at a single place, fabricated on a, you can say, in a single unit. It is usually consisting of the electronic components like resistors, capacitors, and active components like transistors and diodes, connected in a specific manner so that it can be used as a single unit. So in on your screen you can see the an example of an IC, integrated circuit. It is a digital IC. So this is a simple example of an IC. This is a simple example of an IC which is consisting of several electronic components like resistor, capacitor, diodes and transistors placed inside this small case or small unit. And we have different pins over here. See, these pins are pins over here, by which we can make connections and to this to those components that are placed inside this single unit. So now we will see how to number the pins or identify the pin numbers of the IC so that we can make connections to the components that are present inside the IC. So here in this case we are going to see the digital IC, but the numbering is almost same for all the ICs, whether they are digital or analog. So here, for example, here in this example we have taken a digital IC. So in every IC that you will have over here, you will find a notch. You will find a small cut on either side of this digital or either side of this this IC. So here we have a small cut or a notch over here. So starting from the left side of the notch, we will start the numbering in anti-clock direction, anti-clockwise direction, right? So here it will be pin number 1, pin number 2, pin number 3, pin 4, pin 5, pin 6, pin 7, pin 8, 9, 10, 11, 12, here 13, and this will be pin number 14. Always we will keep the notch in front of us, and from the left hand side of the notch, we will start counting from the notch itself, right? So from here we will start counting and number these pins in anti-clockwise direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Here in this case we have taken an example of a 14 pin IC. You will have different number of pins, so the process of counting the pins or identifying the pins will be same for any number of for ICs with any number of pins. You will start from the notch, from left hand side of the notch, top side of the notch. Starting from 1, you will go anti-clockwise till the last number. That is the final count of the number of pins of that particular IC. So taking an example here with this second IC, how we are going to number it. First we will find the notch. So here, so we are taking a second example over here. In this case, this IC, सबसे पहले what we have done is we have to find where is the notch, half cut notch. See, here is the notch. From the left side of the notch we will have to start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and finally 14. It is also, this one is also a 14 pin IC. Now that we have seen how to identify the pins of an IC, now we will be seeing what actually is the content of an IC. IC here means we are talking about a digital IC. So here we can see an example of an IC whose number is 7400. We will be discussing about how to find the numbers and what this number signify. So here is the internal content of an IC. This IC is consisting of 4 NAND gates, right? So this is consisting of this IC 7400 is consisting of 4 NAND gates, where we can see that for the first NAND gate, its input, one of the input pin is at pin number 1. Second input for the first NAND gate is at pin number 2, and at pin number 3 we are getting the output for the first NAND gate. Similarly, pin number 4 we are having the input of the second NAND gate, and pin number 5 we are having the second input of the second NAND gate, and pin number 6 we have the output. So as we have already seen how we are numbering this IC, starting from 1 to 7, 8, 9, 10, 11, 12, 13, 14. From pin number 1 and 2 are the inputs for this NAND gate, and 3 is the output. Suppose you have to realize a NAND logic, suppose you have to use a NAND gate, so you can simply make connections over here. You can simply connect one of the inputs at pin number 1, the second input at pin number 2, and you get the output. Suppose you want to test it by connecting an LED, then simply you can do like this. As another example, we will see the IC 7404. In 7404, in this IC 7404, this is the pin configuration. Now we have to start the counting the pins from the notch. Pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and here it is 14. So now here we can see that this IC 7404 is consisting of many number of NOT gates. Since we know that NOT gate is a single input gate which accepts single input, take a single input and gives its output, the complement of that input that it has accepted. So